Hello and welcome to the SpaceX Transporter-2 rocket launch. We're back for the second day to see if today we can have a successful launch of this mission. So, as we mentioned, there are two satellites that we've built for this mission today. One of the satellites is the Tiger-2. This is a dedicated mission for OQ Technology. OQ Technology are the world's first 5G Internet of Things satellite operator. They provide global cellular Internet of Things and machine-to-machine communication solutions through satellites in low Earth orbit. The Tiger-2 mission is the latest addition to their growing constellation of nanosatellites, and it's the second mission that's being done in collaboration with Nano Avionics.
LWO1 WeatherNet, liftoff conditions looking pretty good.
ESTS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8.
Side booster ignition.
6, 5, 4, 3, 2, 1.
Good afternoon. It's Wednesday, June 30th, and we're here at SpaceX's headquarters in Hawthorne, California. You're looking at a live view of Falcon 9 as it awaits its 3:31 p.m. Eastern Time launch from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicles pitching downrange.
First stage chamber pressure is nominal.
We are T plus 42 seconds into flight. Falcon 9 has cleared its tower, and we're currently throttling down in preparation for max Q. That should be coming up in about 20 seconds. Max Q is where the vehicle will experience the highest amount of aerodynamic pressures.
Falcon 9 is supersonic. Max Q.
And you heard the call out. We've passed the period of maximum aerodynamic pressure. Falcon 9 is now headed south along the Florida coast. All is looking good with the first stage trajectory. We have 5 events coming up in quick succession in about a minute. The first is main engine cutoff, also known as MECO, followed by stage separation, where the 2 stages will separate from one another. The first stage will then perform a flip to head back towards Florida, and the MVAC engine on the second stage will perform second engine start 1 and ignite that MVAC engine. Then the first stage will also begin its first of 3 burns, the boost back burn. And this is a view from the top of Falcon 9 looking down towards the 9 Merlin engines at the bottom of the first stage.
Stage separation confirmed.
And you can see the Florida coast and landing zone 1 are approaching on the left-hand side of the screen as this booster makes its attempt to land for an 8th time. This is a great shot of the first stage coming down with its landing burn.
Stage 2 in terminal guidance.
Stage 1, London light deploy.
That was as smooth as I'd seen it. We had phenomenal shots all the way through the landing burn. You heard the sonic booms. This booster has landed for the 8th time. That is the 89th recovery of an orbital class rocket.
Stage 1 nominal landing confirmed.
And what a way to start
Nominal
off
orbit
the
insertion.
Transporter-2 mission. At the same time, we did have successful second stage, second engine cutoff, and confirmation of a nominal orbital insertion.
Hello and welcome back. If you've just joined us, you're tuned into our live stream of the SpaceX Transporter-2 rocket launch. The Falcon 9 rocket is now in its coasting phase, so we have some time for discussion. And we'll start with the Tiger-2 satellite. The Tiger-2 satellite is a dedicated mission of OQ Technologies, and I'm very happy that we're joined now by Omar Qaise. Omar is the CEO of OQ Technologies. Can you give us a wave and say hi, Omar?
Hi, nice to meet you. Hi, everyone. So thank you very much for this kind intro. So I'm Omar Qaise, founder and CEO of OQ Technology, and I'm very happy to join you today from the States in the show.
It's brilliant to have you with us. And let's get straight into Tiger-2. So it's on its way up to orbit as we speak. Could you introduce Tiger-2? We know it's not a rideshare mission, but it does have a couple of different payloads, doesn't it? So tell us about those and tell us what's new about this satellite.
Yeah, so as you know, like OQ Technology is the world's first global operator for 5G Internet of Things connectivity. So we're trying to build this hybrid system that can provide connectivity anywhere in the world for mobile IoT users by a combination of terrestrial and satellite connectivity. And the Tiger-2 mission is really very critical because in Tiger-1 mission, we did prove our technology that 5G IoT can work over low Earth orbit satellites. Now, the Tiger-2 came really in order to address customer-specific needs. So we have this pipeline of customers that now want to have a taste of this service that we want to bring to the world. And they are lining up to start this service. So we put a payload that is going to start the preliminary 5G IoT service to those users. And then we added another payload also because one of the critical aspects of the Tiger-2 mission is also to facilitate strategic access to very critical frequencies. And 5G, there's a discussion 3GPP of covering multiple bands. Some of these bands are also on the high end of frequency, and we were trying to get access and also test the capability in future to provide like higher data rate access to 5G for users. And so we used the opportunity because our payload, we have a 6U platform from Nanoavionics. We have a main payload for the customers, but we have enough space also to add another payload. And that's why we decided, okay, let's add this other high frequency payload, which is also dedicated for 5G, which will not be used for customers, but mainly in order to pave the way for, let's say, extra validation for future products in the 5G aspect.
Fantastic, really exciting to see that combination of something directly for the customers now and also something that you're building and innovating for the future. You mentioned that you're the first 5G IoT operator that's building this hybrid system. Can you tell us a bit about the limitations of cellular networks that made you go up into space in the first time? And what are some of the opportunities that narrowband IoT services from orbit provide to those end users and individuals?
Exactly. So as you know, the cellular coverage is limited to where the cell towers can reach, and mobile operators during the past decades have deployed infrastructure that covers mainly urban areas. So we're talking about best case 20% of the world mass of land but you have also the oceans which are not covered. You have like the mountains, the deserts, and honestly, even like for in many populated areas, you still have some poor coverage. Now, with 5G coming, as you know, 5G has different services. So there's the broadband service, which is dedicated, let's say, for people, voice, video, and all that. But there's what they call now the massive machine communication. So the number of devices, sensors connecting now to the internet is increasing humongously. It's multiple times than the number of people using the internet, and it's projected to increase like to 50 billion devices connect to the internet. And 5G want to address the connectivity of these devices. However, this is going to be restricted only in urban areas. And we're trying to do is really to bring this 5G massive machine communication capability and revolution into the rest of the world. For example, if we look at third world countries like whose operators still are deploying GSM or let's say LTE, it will be a long time until 5G can be deployed there. What we are trying to do is really to be a global operator. We can bring this connectivity using infrastructure in the sky to everyone in the world and really democratize the access to 5G massive machine communication. And this has really big value for enterprises, for users who rely on these machine data for their operations.
Wow, that's a huge mission and a really important one that you're driving there. And clearly the importance of building that satellite network is very obvious from what you've said, but there must be some challenges that come along with implementing them. What kinds of problems did you have to solve over the years to make that narrowband IoT services from low Earth orbit possible and reliable and applicable?
Yeah, exactly. So the cellular technology is really great. It's made to address massive number of users. This is by nature. And it's global. So you have this ecosystem of users and operators everywhere in the world. It's not like a silo technology, dedicated proprietary technology. Now, the challenge when we looked at the beginning in 2017, how can we make this work on a satellite? So for a user, it looks seamless. It's as with the same chip he's using on a terrestrial network, he can use that on a satellite network, and then we'll have ubiquitous coverage everywhere. So a lot of technical challenges really, because first of the distance, like, you know, imagine the cell tower now is a few kilometers away, but in this case, it's like 500 kilometers away. Then the speed, so the satellite move, like the fastest connectivity, a moving object where you could still have a good cellular communication on Earth is a fast train around 300 kilometers per hour. Here, the satellite is moving about 7 kilometers per second. It's like a bullet. So imagine you want to keep cellular connectivity while you're moving fast as a bullet and being very far away. And these were the challenges that we addressed in our patents. Then we started prototyping and working with the technical experts and the partners over the past 4 years in order to address that. And this is now, you know, being crowned with this launch of Tiger-2 to see this life coming to users. And of course, there's still a long road of optimization and developing, but we feel we're really very happy and proud of what we achieved within the past years.
Yeah, as you should be. You mentioned the users there. From a user's perspective, then, how does your service work, and who could be benefiting from Tiger-2's coverage?
Yeah, so mostly like we're looking into sectors, for example, the energy and oil and gas sector. We're looking at logistics and land transport big time, and agriculture. So today, for example, if you have a fleet of trucks that you need to track and you're reliant of mobile communication, the moment you go out of coverage, you lose a signal. There's no more coverage. You need, and if you need to have access to monitor your assets, let's say your trucks, then you'll need a satellite solution. The cheapest satellite chip available right now is like, you know, $100 and up. They're very expensive. And imagine if you have like millions of assets that you need to track. This is a challenge, even thousands of assets. Now, the cellular chip is around $4 or $5. Imagine that chip now can do the same job as a satellite chip. Then you have a huge opportunity, a big market. So these users, the cost of ownership will really reduce to them. So if they are dependent on a certain operator, mobile operator, they can go out of that coverage and still be connected anywhere in the world using the same hardware they have. All they need to do is really just get the service, the megabytes per month from us, the SIM card, and boom, they are connected anywhere they go.
Beautiful. You've talked about the price point there. What other things make OQ different from other satellite IoT operators, and what kind of market and commercial opportunities are there for OQ going forward?
Yeah, so if we talk about the pricing here, really we're trying to be similar to terrestrial network pricing. Satellite has been always expensive, prices have been high, and users have been very shy to deploy satellite service unless it's really critical. We're changing this, we're democratizing it. So we're talking really being 100 times cheaper than a new entrance into this field, to 10 times cheaper than incumbent operators. So really, like, this opens a lot of opportunity in addition to the scalability. So we are tapping into a standardized technology that exists everywhere in the world. There's 3GPP, standardized technology, cellular, 5G. So we're not coming up with a very proprietary solution that we need to build the ecosystem from scratch. Also very important, we have a frequency access, which is very critical. A lot of operators don't think about that challenge, regulated challenge, and luckily we have very good partners we work with, and we have secured that. In addition to the patents that also provide a barrier to entry. But from a perspective for users, really the low cost, the breadth of data they could have, so we can really go beyond just the simple tracking solution. We can even provide, let's say, low resolution images, voice, even low resolution video. For some applications, security cameras, border monitoring, such things are needed. So really we have a lot of advantages with what we do with respect to the end users.
Fantastic, Omar. Huge potential, and so exciting that Tiger-2 is going to be part of that process and that democratizing mission. Thank you so much for speaking to us now, and do stay with us because let's get your reaction once we see that satellite deployed.
Oh, so excited about it. Thank you. Thank you very much.
Brilliant.
D2 Athlacom 1, separation confirmed.
Now let's speak to some of our guests and get their reaction on the news that we've had a successful deployment. So Omar, let's turn to you. How are you feeling right now? What are your final words or messages that you want to give out to the audience there?
I'm so excited about this, really, and it was so wonderful to watch. I'm actually on site, not too far away from the launch, and I've seen it, and the Tiger went up. It's really amazing. I can't describe this feeling. It's a changing moment for the world of telecommunication, of both satellite and cellular. And really, I'm looking forward to the first acquisition of the signal of our satellite from Nanoavionics. And really what I could say, like, starting from this moment, this is a change in the telecommunication service. Mobile and satellite are not going to be the same anymore. I mean, these two worlds are merging together. And for end users anywhere in the world, really, we are looking to bridge this digital divide between urban and non-urban areas. And that is starting with our Tiger-2 mission. So I'm really looking forward to this big change and big impact that we can bring to the world.
Brilliant. Well, good luck with that mission, and congratulations to you and the team for that successful deployment. And I hope that that further mission continues successfully.
Thank you very much. And thanks to all our partners, suppliers, contractors, funders who helped us to achieve that. I'm really looking forward to continue our relationship.
Fantastic. Brilliant.